Okay, what we're looking at here, this is an application from a company called RTT, and this is their DeltaGen application and framework. It's a software package that's used extensively in design and manufacturing for doing very high quality photorealistic design reviews. It supports ray traced rendering for very accurate paint simulations and headlight and taillight simulations, for example, in automotive. It also supports global illumination, so objects lighting and reflecting light onto each other rather than just single point light sources. But on this demo, we're using a Maximus workstation to not only show DeltaGen and the photorealistic graphics that it displays for design reviews, but we're also using the Tesla GPU that's part of the Maximus system to do a real-time computational fluid dynamics simulation. Now this is really interesting and important because historically an automotive stylist would make decisions based purely on how something looked, what the shape of the mirror is, the position of the mirror, its angle. And it wasn't until much further down the line as part of the engineering process when they would figure out that there was an issue with how the air was flowing around that mirror. And the concern, especially with a side mirror in this example, is air coming off of that mirror and being turbulent and buffeting against that driver's side window. And that air hitting that driver's side window shows up as wind noise, an undesirable amount of noise for the driver. But for the first time now, an automotive stylist, as a part of the design review process, can see real engineering, mathematically correct fluid dynamics information to get a good gauge of what's going to happen to that airflow with the current mirror position, with the current mirror design or size. And so now they can start making better decisions sooner about how that airflow is going to behave. So now further down the line, when you're actually doing the design engineering of the vehicle, you're at a much more final solution on where that mirror shape or mirror position is going to be. And the goal is always to make better decisions sooner, because the more decisions you have to make later, the much more expensive they get to correct or make changes. But even more important than that, it adds time to the process of trying to get the car engineered, developed, and to market. So this is the power of GPUs now. They are completely programmable devices. They're just giant math engines, and with those math engines, you can do real-time 3D graphics. You can do GPU-powered real-time ray tracing with all kinds of advanced techniques, such as global illumination. But you can also use those very large math engines to do computer-aided engineering, whether it's structural mechanics, structural dynamics, and in this case, fluid dynamics around the vehicle while you're visualizing it.